All right, today we're going to get into lesson 6.2, which is on angle bisectors. And the focus is, this whole module is on triangles. And so we're going to look at angle bisectors on triangles and what that does for us and how we can use that in some different ideas. Okay, the first thing is, let's just set the scenario up here that you are an urban planner. All right, and you've been commissioned to decide where this new subway station should go. All right, they want you to plan the location of this subway station so that it is an equal distance from the three roads in the city. So here it is right here. Here are the three roads. You need to locate the subway station somewhere inside this triangle. I just superimpose it over here inside the triangle so that the distance from the subway station to PR, subway station to QR, subway station to PQ is all the same. Now, this is not what we did yesterday. Yesterday is when we found a point that was an equal distance from the vertices. Okay, that's a circumcenter. Today, we're finding a point in here that is an equal distance from the sides. And when you travel from a point in here to the side and you want the true distance, you have to be going perpendicular to the side. Okay, so that's a different technique. All right, it's going to call for us to do some different things. So your job as an urban planner is you got to put a point in here that's an equal distance from these three sides. We'll come back to that idea in a minute. Let's talk about angle bisectors first. An angle bisector is a line, a segment, or array that divides the angle into two congruent angles. So bisect, cut into two equal parts, right? The angle bisector theorem, okay, looks like this. So here's my original angle, DBE. Okay, BF has been inserted as a bisector. So BF is going to divide the angle into two congruent angles. DBF and FBE are the same angle. All right. And what happens when that occurs is that any point along this bisector, because it is a angle bisector, it bisects the angle, any point along this line is an equal distance to the sides of the original angle. At F, I could come out here a ways and go back, and it will be the same distance. I'm going to do it here. It's the same distance. So that's a key part of this. And notice that when we talk about the true distance, we're perpendicular to where we're headed. F to the side BE, I got to be perpendicular. F to side BD, I got to be perpendicular. Okay, so that's a key part of it, is that when we put in an angle bisector, the points along that angle bisector are always an equal distance back to the sides. Okay, so now take that concept and look at it in a triangle. So obviously in a triangle, I got three angles, the three angles of the triangle right here. I put in the three angle bisectors. So B to P bisects angle B. A to P bisects angle A, and C to P bisects angle C. All right. Now, whenever you put, I don't care what kind of triangle it is, whenever you put its three angle bisectors in, they're going to meet at a point. Remember, a point of concurrency. This point of concurrency is called an incenter. All right. So an incenter is a point of concurrency for the angle bisectors, and the incenter is an equal distance from the sides of the triangle. So PE, PF, PD are all congruent. Okay, that's what happens with an incenter. An incenter is created by angle bisectors, and an incenter is an equal distance from the sides of the triangle. It's called an incenter because it is the center of a circle that could be inscribed in the triangle. If I was to inscribe a circle, and I'll show you this here in a minute, inside the triangle, so this was the center, this circle would just touch the triangle at E, D, and F, making them radii of the circle, which makes them all congruent. Okay, so we're going to use this concept in our problems tonight. Now let me go back to our original problem. Okay, where should we locate this thing? All right, well, we want to locate this at the incenter of this triangle. All right, to find the incenter of the triangle, I got to do the angle bisector for all three sides. So here is the angle bisector for P, and then we'll do the angle bisector for Q, and then the angle bisector for R. And notice that when you put in all the angle bisectors, they meet at a point right here, point S. Point S is the incenter for the triangle. It's the intersection of the three angle bisectors. Point S is an equal distance to the sides when you go perpendicular. So S to PR, S to QR, S to PQ. So that's in essence us walking from the new subway station to the streets in all directions. You walk the same distance. All right. Now, remember, I said it was the center of a circle that if it was inscribed in the triangle would just touch the triangle at these 3 points, making them the radii, making them all congruent, kind of proving that point. Okay. So when I want my point to be an equal distance from the sides, I want the incenter. To get the incenter, I have to do angle bisectors. Okay. All right. Now let's look at the problems you're going to get tonight. So they give you a descriptor here. The key is this, guys. As soon as they tell me that Z is the incenter, I know a couple of things. Number one, I know that Z to Y, Z to X, Z to W, all the same length because an incenter is an equal distance to the sides of the triangle. Number two thing is I know that these are all angle bisectors. I know PZ bisected this angle. I know that QZ bisected angle Q. And I know that RZ intersected or bisected angle R. So these two angles are congruent, these two are congruent, these two are congruent. And I know these are all equal distance. So we got a lot of information just by knowing it's an incenter. Okay. Now they give us some numbers to put in. Okay. They tell us Y to Z is 17. So guys, just by our labels we put in, if Y to Z is 17, then Z to X is 17 and Z to W is 17. Okay. They tell us Q to Z is 18. They tell us angle WPY is 92. So guys, WPY is this whole angle. Now we've cut it in half here, but the whole angle is 92. Okay. And then they tell us XQZ. So X, follow the letters here, XQZ, just this angle is 24. All right. Well, if this angle's 24, this one's 24 because these two are congruent. So there's our givens. Now they're asking us, hey, find this information. All right, find the measure of angle XQW. All right, well, let's go find XQW here. XQW. So they want this whole angle, XQW. Well, I kind of wrote it out that XQW is equal to the sum of the two angles here, XQZ and ZQW. It's equal to 24 plus 24, and XQW is 48 degrees. So this whole angle Q here is 48 degrees, and that's what they're asking. Okay. All right. Next thing, find WZ. Well, in your drawing, find WZ. Well, we already labeled it, WZ 17. Got it. Lastly, find XRZ. So XRZ, when we go over here and trace the letters XRZ, they're asking me to find this half of the angle. Okay. Well, I don't know what the whole angle is, so I don't know what half of it is. So this one, we're going to have to think a little differently. What I want you to do is think of the entire triangle here. We know that angle P plus angle Q plus angle R has to equal 180 because they're the three angles of a triangle. I know angle P is 92 because they told me that. We just figured out that angle Q is 48. That's what we did first. So now that's going to let us find angle R. Okay. If I add 92 and 48, I get 140. Subtract this angle R. The total angle is 40. We want XRZ, which is half of it. So XRZ is going to be 20. So this XRZ is 20. Okay. That's our process. Now, when you do the homework tonight, you have to turn in work tomorrow. And the work is you're going to draw I want you to draw the triangles, put the labels in, add your numbers in, and show this work. All right. I want you to draw all these. So I will collect that tomorrow. All right. Let's do one more. Same deal. Here's the given information. They tell us G is the incenter. As soon as they tell me G is the incenter, I know that these distances are all the same. And I know that it was created using angle bisectors. So I have all this information. Okay. Here's my givens. E to G, 18. Well, if E to G is 18, D to G is 18, and G to F is 18 because I know it's an equal distance to all the sides. Okay. Z to G is 27. EZF. So go find EZF. EZF. So this whole angle, not one or the other, the whole thing here is 22. I'm just going to put it right on the line. This whole angle is 22 degrees. DXG here, DXG, just this half of this whole angle is 32. That means this half is 32. So hopefully you see the difference in how these are labeled. All right. Now we got to find DXF, DYG, and DG. All right. So angle DXF. We'll go over here and find DXF. Well, that's just this whole angle X right here. And you get that by adding 32 and 32. So this angle DXF, which is really angle X, is 64 degrees. Okay. Angle DYG, DYG. So they want this little half of this angle. Again, we don't know the whole angle, so we can't find half. But what we do know is that angle X, angle Y, and angle Z have to add up to 180. Okay. X is 64. I know Z, remember they said the whole angle here is 22. Okay. 64 and 22 is 86. They're on the same side, so add them together. Now subtract. And angle Y, this whole angle right here, is 94 degrees. So DYG is half of that, right? DYG is half of the whole angle, so DYG is going to be 47. Got it. Okay. DG, well, DG is, we already have it labeled here, right? It's 18. Now, I threw one more question in here because they keep giving us, if you notice in the last question, they gave us an extra number, and in this question, they give us an extra number. They give us this 27, which we didn't use for anything, which makes me think maybe they're going to ask you one more question, and one that they could ask would be find FZ. What's the length of this line? Well, hopefully what you're seeing is you got a right angle, so I got a right triangle, and I can use Pythagorean theorem to find F to Z. That's the only reason I can think they give you this number. All right, so it would be 18 squared. Remember, the A and the B are the sides that make the right angle. The C number is always the longest one across from the right angle. Okay, do the math, and F to Z is about 20.1. Okay, all right, that's the kind of questions you're working on tonight. And I do want you to make drawings for all of them. Okay, create a drawing and use that drawing to help you with the process. All right. All right. I'll let you have at it.